Let me ask you about wireless, because you've got a background in wireless.
Yeah,
so
I love wireless.
That kind of, you have a little bit of a predilection towards that. Give us your background, if you don't mind. Why did wireless pique your interest from an engineering perspective? Your mindset at some point in time, you said, I want to learn more about that. Why?
Well, you know, back when I was working on my bachelor's in engineering, my ultimate goal was to work for the Department of Defense and design radar systems, and so I was working on actually a lot more of the RF frequencies, and was really captivated by how we transport that and through waveguides and everything else. I was really captivated by how that worked, and kind of somewhere along the way, I ended up with a career in networking, and it's kind of funny. I'm like, how the heck? This is not where.
How did I end up here?
Where did this end up here? Well, then wireless started getting a little bit bigger and stuff. And even before that, when I was doing security stuff, I was building my own little 900 megahertz transceiver and, or not transceiver, but transmitter and receivers to actually set up as taps to break into networks. You know, I could sit out in the car and listen to like Ted Nugent tapes on 8-track.
Hacking as a young child, yeah.
Oh, absolutely, you know. And then as problems started happening in wireless, I kind of knew how to solve a lot of them from my background in RF. Like my very first patent I ever got was actually on finding rogue access points. And so that's kind of where I got into it, and just really still love wireless. Got a real passion for it, man.
All right, so, and I would agree. I think wireless is fascinating. I also think that it doesn't, especially for someone who doesn't know what they're getting into, and when we're talking about associate level, we're probably talking about someone who may be getting certified for the first time, and they're making choices about where to go. It's a path they may continue on. They may decide this isn't for me, or maybe they're happy at that associate level. Yeah. Either way, if they're picking wireless, I think wireless as a technology is always one that historically was so easy to get wrong. You know, you can buy access points cheap, you can throw them up. Most of the time they're going to work okay in a home environment or something like that. But we're not talking about home environments here. We're talking about engineers getting specialized to go provide a benefit to their employer, more than likely, or be a consultant, or offer some services that people are going to be willing to pay for. And since at the end of the day, that's what we all want to do, is get paid just a little bit more. If I'm looking at this certification and I'm getting started, what are the things that I need to be aware of in terms of, what do you think are the things that would trip you up on a test, the foundational principles that if you don't get this and really fundamentally understand it, you're going to struggle? When
I was a kid, I used to watch thunderstorms come in on radar, and it used to captivate me by, you could see these radar sweeps, and I'm like, wow, that's passing over my house right now, you know?
Yeah.
You know, it was just amazing that it could do that. You know, wireless is a very similar technology because it's so pervasive, it's everywhere. It's all in this building, and we can't see it, we can see the effects of it, so we have to express it mathematically. You have to really kind of understand the math and the principles behind that. With Ethernet, my direction is dictated by where my cable's at. But with wireless, it's directed by how it's bouncing off of this, how the effect is on this glass down here, how absorbent it is on you. You know, I mean, I'm fatter than you, so 2.4 gigahertz is going to soak up more than me. Does that make you more absorbable? It does. 2.4 gigahertz is water absorbent, so it's going to actually get in there. So where I'm actually placing these things is really, really darn important. So you really have to get a feel for wireless is not Ethernet. It's not even the same frame type. It's 802.11.
Yeah.
You know, and I'm not using collision detection, I'm using collision avoidance, you know, so there's some differences in here, and the big mistake is to go in and treat it like Ethernet, but any wireless access point is a bridge. I'm bridging 802.11 over here, that's, you know, all this stuff, into a directional 802.3 right here that's actually sending it to my network, and everybody's getting plumbed in. So it's really understanding how I do that, and some of that terminology we use is stuff like signal-to-noise ratio. I've got to be able to find an SNR to say, okay, my signal's up here and my noise floor is right here. Right. The better signal I got up here, the better quality I'm going to get. I'll put it up my face so nobody can see me again here. So the better that, so you know, anytime I raise that noise floor, the crappier my signal is going to be. And understand the relation, and it's all logarithmic. When we're talking about wireless, we have to understand that our numbers really don't mean the same value that we place on them. It's not a scale of 1 to 10, it's a logarithmic scale. Right. So as I start logarithmically climbing,
oh, so you're going to double quickly.
Numbers double, right? So if I'm saying, okay, I got a negative 17 dB on this wireless access point, and I'm looking at putting an antenna on it to shape it, I'm like, well, I can pick a 3 dB or a 6 dB, I'll pick the 6 because
bigger
it's got more
numbers
power.
Are always better.
Hey, why not?
Right.
But 3 dB in wireless is a magic number. It doubles the power. Anytime I hit that 3 dB
so
marker,
6 is going to triple it.
6 will triple it. So now I've got to be very careful, and especially in wireless. Wireless is so great because it's in what's called the ISM band. Any type of radio signal, we have different bands, J bands, K bands, ISM band, which stands for Industrial, Scientific, and Medical, which means that it's unrestricted, that if I'm designing any components out there that give off any type of signal out there, if I operate within that ISM band,
okay.
that 5 gigahertz, that 2.4 gigahertz, that I can operate there pretty unrestricted.
But there's a play-friendly type of thing there,
and that's exactly right,
okay.
right? You're responsible for your leakage of those access points. So I can't set up access points in this building. I can't go ahead and set up all these APs and say, crank up the power, have at it, have a nice day. Because
more is better, right? But the problem is you're stepping on someone else and inhibiting their ability to be effective. And
then call the FCC. They've got an attack against you, and then they can actually fine you for that.
But what's the, well, this is another subject, because I just get, what's the measurement of that, right? Is it don't do more than 6? I mean, it's not something that simple, right? It's kind of it's an idea. If you're in an environment where there's people competing for it, that's what you need to be respectful of. There's not a magic number that you have to stay beneath, or is there?
It really does depend a lot on what is I'm expecting out of my access points. You got to understand that we're used to Ethernet. We're getting 100 meg. We're getting gig to the desktop. We're getting 10 gig. We're used to that dedicated bandwidth. Yeah. Wireless is not like that. Wireless is shared. Yeah. So if I want 54 megabits, then I've got to look at my signal to noise ratio being 25. Okay. If I want 1 megabit, my signal to noise ratio can be 4, right? So I got to keep lowering that floor, right? So SNR, my signal to noise ratio is basically what you're looking at. The definition is it's 20 times the 10 log amplitude power is what my SNR actually is. So it's signal over noise is basically what it amounts to, logarithmically speaking, and that's how I determine this. And a lot of good packages like the AeroNet site survey stuff.
AeroNet, you're whipping out some old terms. That's good though.
Very cool, but they still call it that.
Yeah.
Is that you can actually use that to actually site survey this. If you got the wireless module, it can do site surveys for you as well. But the trick is using the access point you're going to use to actually deliver that signal out there, and then making sure that you don't have leakage anywhere. So if I don't want my signal to leak outside of Moscone here, then I'm taking my laptop outside and I'm checking that with a standard signal. I'm checking that with my standard access door, not plugging antennas up to it, because then you're kind of changing. Anytime you add an antenna, you always change your gain out. And so that really does change a lot of things. Now you're talking about the testing end as far as being able to receive, where's my leakage occurring. Yeah.
Which raises the question, because we talk about this kind of throughout the show, if I'm an engineer and I'm working on becoming specialized in this, does wireless, are there risks in terms of gear I need to have available or software applications that are going to drive me broke that I need to learn how to operate?
No, see, that's a good thing about wireless is that out of all the technology, it's probably the lower cost type of solution out there. The gear's not that expensive. You can pick it up really cheap. And that's also why people kind of minimize them. It's wireless, whatever,
Yeah.
But it's the easiest vector to break into a network. It's the easiest way I can steal your data. It's the easiest way I can get a fine from the FCC. And it's the easiest way I can have more data leakage out of my network. So unfortunately, that's where we, honest to goodness, really need a specialization is in the wireless area, because we need folks that are going to be able to know how to shape and mold that signal. Those signals, when you're looking at antennas and stuff, they're based in a 3D plane, and so it's good to look at that spatial diagram and look and say, okay, my signal's coming out, and I'm looking at side lobes and main lobes. I'm kind of designing my network based upon where my radiated effect is for my site. Plus, I need to look, so you got this big, so you're looking at, here in Moscone, I'm looking at what's my distance for Ethernet. Well, it's 100 meters, right, 328 feet. So if I'm looking, I'm like, well, I got more than 328 feet from the center of here to back. How am I going to plumb wireless out there? Because wireless access points don't have fiber optics.
Right.
Am I going to do it with power over Ethernet? That type of stuff. So
there's a foundational level of knowledge. It doesn't ever go away, right?
No, it really doesn't.
That route switch is always right there.
Route switch, it's always right. And I think that is wireless is probably one of the more compatible technology like route switch. If you want to be route switch and you want a really good add-in, wireless is really good to have in there. I mean, it's a great certification, but the tricky thing is that you got to understand that wireless is three-dimensional. It's like Play-Doh, man.
It's very location dependent, right?
Very much.
How many stories have we heard about customers? You talk about deployment issues and such like this, where the wireless worked perfectly because we deployed it before we got all the shelves into the warehouse, before we actually had trucks rolling around.
Or I bring people into a conference room.
Yeah.
And
everything affects the signal, right?
Means everything, right?
Yeah.
I mean, I plugged in I've got my standard built-in card on that laptop, and it kind of blows. I plugged in my Ubiquity card, which is strong enough to like sync up with satellites and stuff, and man, I've got signals from everywhere,
Right.
So it really does, so that's stuff you have to really check out when you're building this stuff out. Get the strongest card you can get, which right now is a Ubiquity card. Get one of those, and then get the card you plan on using, and then do your testing so you understand where your leakage is and what people are getting up. Secure those vectors. Wireless is one of the best vectors to break into a network and get data leakage like crazy. So secure that out. I'm a humongous fan of centralized management, like with WLC and stuff like that.
That makes a ton of sense.
And the farther you climb, the more you do that. But that really makes your wireless stuff so much more easier.
But you know what, if your passion for wireless is not already selling somebody on the desire to learn more about it, then I don't know what else would.
It is happening, man.
I'll be honest. I think that is good stuff. If you guys are interested in learning more about how do I get certified in wireless, what do I do next, how can I interact with my peers to learn more, to figure out what speed bumps they've already made it across, if you've not already checked out the Cisco learning environment, the links can be found in our show notes, or you can always go to our blog. It's at TechWiseTV.com. Please check it out. You do yourself a favor. This is one you should seriously consider.